In this video, we'll be looking at how to solve a quadratic equation by factoring. Now, there are a few criteria that you need to meet before you actually factor. And the most important one is that one side must be equal to 0. So everything has to move to one side. And also, your equation, if it's not already factored for you, it needs to be in proper standard form in order for you to factor it properly using whatever method you need to use. Once you have factored your equation, you will set each bracket equal to 0 to solve for x. And the reason we do that is because we know that anything times 0 is 0. That's why our goal is to make one side equal to 0. That way, if you can figure out x to make one bracket equal to 0, it doesn't matter what's going on in the other bracket. Left side will equal right side, which will equal 0. So let's try our first example. It's already factored for us. So all we're going to do here, I'm going to take this first bracket and I'm going to write 2x minus 3 equals 0. The reason I'm doing that is because I'm trying to figure out what is x to make that entire bracket equal to 0. So now it's a grade 9 skill. Bring the 3 over and divide both sides by 2. So x equals 3 over 2. That is one possible solution. So that means if I put 3 over 2 into this equation, on the left side, the first bracket will be 0. The second bracket will be about 7.5. But it doesn't really matter because the minute one bracket is equal to 0, 0 times anything is 0. So left side will equal right side. So that's one potential option. Then we'll do the same thing with the other bracket. So I'm going to set x plus 6 equal to 0. I'll bring the 6 over, and it becomes negative 6. If I put negative 6 in that bracket, negative 6 plus 6 is 0, perfect. And 0 times anything is 0, so I have made the equation true. In B, it is not factored. One of our sides is equal to 0, so that's good. And when I look at this trinomial, I notice it's a simple trinomial because the coefficient of x squared is 1. So I will use my shortcut, although you can do decomposition as well. So our product is negative 3, our sum is negative 7, and our magic numbers will be negative 10 and 3. So factored, this will be x minus 10 and x plus 3 equals 0. Now it is factored. Now we can set each bracket equal to 0. So when I set x minus 10 equal to 0 and bring that negative 10 over, x can equal 10. If I set x plus 3 equal to 0 and bring the 3 over, x equals negative 3. So if I plug 10 into this equation, I will end up with 0 on the left side. And if I plug in negative 3 a separate time into the equation, I'll end up with 0 as well. If we look at C, there's a little problem, and the problem is that this negative 4 is on the right side. So our first step is going to be to bring it to the other terms so that we can have 0 on one side. So 3x squared, subtract 3x plus 4 equals 0. And now this trinomial is complex because of the 3 in front of the x squared, so we have to do decomposition. So 3 times 4, we need a product of 12 and a sum of negative 13. And our magic numbers here are negative 12 and negative 1. So let's decompose the middle term. So 3x squared minus 12x minus x plus 4 equals 0. The first pair, we can divide out a 3x, and the second pair, although it looks like we can't divide anything out, we can take out a negative 1. So I take out the 3x and I'm left with x subtract 4. I take out the negative 1, I'm left with x subtract 4. The brackets match. So your factored answer is x minus 4 times 3x minus 1 equals 0. You factored it. This is an equation we have to solve. So I'm going to take each of these brackets. So x minus 4 equals 0. When I bring the 4 over, x equals 4. When I set 3x minus 1 equal to 0, I'll bring the 1 over. It becomes positive, and in this case, I do also have to take that additional step of dividing out the x. And we keep our answer as a fraction in lowest terms, never a decimal. So there it is. In the next one, we have multiple things on the right side. So I'm going to bring them over, and when I bring the 3x over, it's going to become negative. When I bring the negative 6 over, it's going to become positive. And I just like to write that little note under the correct term so I can simplify it. So 4x squared, and then I'll have 7x subtract 3x. So that's 4x's in total. And then negative 5 plus 6 is positive 1. Now, you might look at this and say, oh, I'm going to do decomposition, which would be fine. However, this might be a perfect square trinomial because the outside terms are square rootable. So if it is, I would have 2x. Because the middle term is positive, I'll write plus, and the square root of 1 is 1. And it'll be the same bracket twice, which you can write like this, like the bracket squared, or you can just write it 2 times. For solving equations, you might like to write it in the second variation better, just to clearly see your brackets. Now, as a quick little check, to make sure it was a perfect square trinomial, I would take the 2x and the 1 and double them. And when I do that, I get 4x, which was that middle term. So I know I've factored it correctly. And now, because it's the same bracket twice, I really only have to set one bracket equal to 0 because they're identical. So I would set 2x plus 1 equal to 0, bring the 1 over, becomes negative, and then divide both sides by 2 to get x equals negative 1/2. Now, technically, we do have 2 solutions. They're just identical. They're both negative 1/2. All right. So for e, we have 2 terms, and you might think it's a difference of squares, but because x has an exponent of 1, which is odd, you can't square root it. Also, 6 can't be square rooted. This is just a greatest common factor right now, and both terms have a 6 that can be divided out and an x. So we take out the 6x, and we're left with x subtract 6, and now this is factored. You can treat this 6x as if it's in its own bracket. So when we branch out to set our brackets equal to 0, we'll say 6x equals 0. And we'll just divide both sides by 6, which gives us 0 as one answer. So if I plug in 0, I will get 0 as well. And then I'll set x minus 6 equal to 0, and when I bring the negative 6 over, it will become positive. So make sure you remember about that greatest common factor because sometimes that's the only method. For f, this will be a difference of squares. Now, when you look at f, you can actually solve this by isolating as well, but you do sometimes have the option, if it's a difference of squares, to factor it. Depends on how you see it. So remember, with a difference of squares, it's going to be the same bracket with opposite signs. So the square root of 9x squared is 3x. The square root of 1 is 1. One bracket will be plus, one will be minus. And now when I branch out, 3x plus 1 equals 0. We bring the 1 over. It becomes negative. Divide both sides by 3, and one of your answers will be negative 1/3. Because the second bracket was almost identical, the answer will be the same except the other sign. So I bring the 1 over, it's positive this time. When I divide by 3, I get positive 1/3. And these 2 options of plus or minus negative 1/3 is what we would have gotten if we solved by isolating. All right, our last ones, they look a little different because there are brackets in there. Our sides are not equal to 0, so it's a little problematic. First of all, we should get rid of all the brackets. So we have to do some distribution, then bring everything to one side and do our factoring method. So in the first one, I will distribute the 4x in to get 4x squared subtract 4x, and then distribute the 2x in to get 2x squared plus 6x. Now let's bring everything over. When I bring the 2x squared, it's going to become negative 2x squared. And when I bring the 6x over, it's going to become negative 6x. And again, I'm writing it under the correct like term to simplify. So 4 minus 2, I have 2x squares. Negative 4 minus 6, I have negative 10x's. Now I have 0 on the right side. This is similar to E in that we have just the greatest common factor. We have two terms, they both have an x, and they're also both divisible by 2x. So when we divide out the 2x, you're left with x minus 5. And now a quick branching out. When I set 2x equal to 0 and divide both sides by 2, 0 will be an answer. And anytime you have a common factor that's a variable, 0 will be a solution. And then x minus 5 equals to 0. We bring the negative 5 over, and it becomes positive. And then that's it. And finally, the last one. It looks like there's a lot going on. First thing, let's clean it up. So we have to distribute that negative 2 in. So the left side stays. The 2x squared stays. But now we have negative 2 times x, negative 2 times 2. Now we can bring everything over. So the 2x squared becomes negative. The negative 2x becomes positive, and the negative 4 becomes positive. So when we clean this up, 3 minus 2 is just an x squared. Negative 2 plus 2 is negative 8x, and 11 plus 4 is 15. So why don't you pause the video here just for our last one where you factor and solve and then come back to check your work. So you might have done this with decomposition, which would be fine, and said product is 15, sum is negative 8. I'm going to do it as a simple trinomial just because it's quicker. So your magic numbers should have been negative 5 and negative 3. And even if you did decomposition, you should have ended up with x minus 5 times x minus 3. You factored it, don't forget to solve because this is an equation, and you know it's an equation because the equals 0 part. So when x minus 5 equals 0, we bring the negative 5 over, it becomes positive. When x minus 3 equals 0, we bring the negative 3 over, and it becomes positive 3. And that's it for solving by factoring. So isolation is used in those two scenarios where you have a bracket squared or just an x squared term. Whenever you see that your expression has an x squared, an x, and potentially a constant, you have to factor. You have to make sure one side is equal to 0 before you factor. You have to make sure it's in that nice standard form with no brackets before you actually factor it properly. Okay, and once you factor, you set your brackets equal to 0 and solve the mini linear equation that you're left with. And that's it.